Today on Inevitable, our guest is Hudson Gilmer, co-founder and CEO of LineVision. LineVision is a Series C stage startup that helps utilities monitor and even increase capacity for the vast network of transmission lines that serve as the vascular system for the U.S. electric grid. The U.S. transmission grid consists of 600 to 700,000 circuit miles of high-voltage transmission lines, connecting energy generation with consumption and sending power across the country. And this is infrastructure that generally persists for decades and decades and decades. Most of the transmission architecture in the United States today was built in an era before any sort of sophisticated software-based monitoring or even persistent connectivity was contemplated. LineVision provides a non-contact sensor plus software system that can detect issues with lines and can even help grid operators safely increase the capacity of existing lines, which is critical in an increasingly electrified world in which our grid faces real constraints in its ability to deliver power, and in which building all new transmission lines is a painfully slow process that can take years and years to complete. Hudson and I discuss all this and more, but before we start, from MCJ, I'm Cody Sims, and this is Inevitable. Climate change is inevitable. It's already here. But so are the solutions shaping our future. Join us every week to learn from experts and entrepreneurs about the transition of energy and industry. Hudson, welcome to the show.
Thank you so much. An honor to be here. Good to meet you, Cody.
Well, I'm really looking forward to this conversation. When you hear about everything that is happening in our world with respect to electrification of our world, it all comes down to how do we move this electricity around, particularly, I think, with renewables, right? You're all of a sudden producing power potentially quite far away from where the power is needed based on geographical features and whatnot of where you can produce that power. And as a result, the transmission grid seems to be one that is increasingly trying to be understood by people on what needs to happen. How do we make sure that we can solve this large demand increase in power that we're seeing because of data centers, because of EVs, because of heat pumps, because of industrial electrification and whatnot. And sounds like you guys are in the thick of trying to help grid owners and operators manage this.
Absolutely. I think for years, no one really was focused on transmission. And now it seems like it's almost daily front page news for all the reasons you mentioned. Just last week, there was a major story about electricity demand from AI and in Bloomberg and in the New York Times. So yeah, we're fortunate to be solving a problem that is important and very front of mind. And yeah, I think, as you said, there's a recognition that we will need to massively increase grid capacity in order to support these loads that come from data centers, that come from AI. There was a study done by Jesse Jenkins and the Repeat projects that said we'll need to double grid capacity by 2035 and triple it by 2050. Massive undertakings for rebuilding what took us 150 years to build. And it's clear that we won't be able to rely on the technologies that were used to build the grid that we have right now. We've got to look to new technologies. And that's really where LineVision comes in.
And this is one of the backbones of infrastructure in this country, right? You think about the transmission electric grid, undersea internet cables, like some of these systems that we take for granted. We don't necessarily see them in our daily lives, but they absolutely make things happen. The interstate highway system would be probably another one I would put up there at that level of complexity.
Absolutely. I think that's a really good analogy. I often will kind of compare the transmission grid with our interstate highway system. And just to give you a sense of how it is operated today, this critical infrastructure, this backbone of our grid, is not monitored today. My doorbell is smarter than the average transmission line. And as such, the utilities who operate those wires are, in a sense, operating them without real-time data. And so they're setting speed limits on these highways, if you will, that are based on kind of worst case ambient conditions. It's as if when you were driving across the country, you had to drive at 35 miles per hour because that is the maximum speed that you could safely drive in a snowstorm, which would be incredibly frustrating on most days when it's bright sunshine and safe to drive much faster.
So the lines are regulated in terms of the throughput of power that they allow today to ensure that they're not overloaded somewhere in a way that's going to cause a fire or cause outage or something like that. Am I following correctly?
Roughly. Essentially, these transmission lines consist of conductors or the wires that you see as you drive along the highway, and the thermal limits are basically set to avoid creating permanent damage to those conductors. And so the static limits that are set assume very little wind cooling the lines, assume high temperatures, when in reality, you drive across the country, there's almost always even a modest amount of wind. The DOE did a study a few years back that showed that 3 feet per second of wind perpendicular to a line increases the amount of power that you can flow through it by over 40%, just because of the cooling effect of that wind. And so what LineVision does is we add monitoring, we add relatively low-cost sensors to these lines, and that allows us to measure the actual conditions along those lines, take advantage of the times when wind is blowing and temperatures outside are cooler, and on average, we're able to unlock 25, 30+% more capacity on those existing lines.
Well, we're going to dive into a bunch on the specific product that you offer and how it works. Let's start with just a little more orientation for folks. When you talk about the area of focus for LineVision, we're talking specifically about the transmission grid, which is high voltage, long distance lines, as opposed to the local distribution grid, which would be like power poles in your city that are sending things around locally where you live today. Is that the right way to think about the distinction?
That's exactly right. So these are, for those who are more technically minded, they're 115 kV and above. Our sensors are actually voltage agnostic. So we've deployed on even down to like 12 kV lines, lower lines. But you're right that where we as a company are focused is on really the high voltage transmission lines. And right now, there's a massive amount of congestion on that system. At a national level, there's about $12 billion per year of congestion on that grid.
And I would think about it as the local distribution grid is actually probably larger, more total lines, more total line volume, but the transmission grid is more critical points of failure, meaning if you have a problem, it causes a much bigger problem. Is that the right way to think about it?
Absolutely. And I think another way to think about it is just from an economic development standpoint, as we look to connect generation to the grid, as we look to connect large loads like data centers or factories to the grid, often those are being connected at higher voltage levels. And so those are the backbone of the power grid.
How is this something you first started thinking about working on, spending your career on?
It's interesting. It depends how far we want to go back. Earlier in my career, I was in the telecom industry and I worked with AT&T, and I'm dating myself a little bit, but I was developing expert systems to optimize data networks. And at the time, data networks were built using circuit switch, they're called digital access cross connects. And so really kind of building tools to optimize where to place those and how to accommodate growth. And during my time in that industry, I witnessed this amazing disruption and transformation that came with packet switching and ultimately the internet, which created tremendous innovation, tremendous value. But I'd always been fascinated by the energy industry and had the opportunity to go back to graduate school and really took that time to focus on transitioning from telecom into energy, I felt like there had already been a lot of competition and technological change in the telecom industry. I wanted to see if we could almost borrow what I learned from that industry and apply it to electric power. I won't go blow by blow through it, but I was working with a company that was called Genscape that had a core technology that was essentially kind of spying on the power grid. So we were selling data and analytics to traders in wholesale power markets. And one of our core pieces of technology was a patented EMF sensor, electromagnetic field sensor, that could monitor flows on power lines without requiring the consent of the utilities. So we'd go to farmers and pay them a nominal amount of money to put this little device on the edge of their right of way. And for the first time, it gave traders in those markets visibility on when a plant would unexpectedly trip offline or how much power was flowing. But that really kind of planted the seed in my mind to say, while that was a great business and continues to be today, that was really helping inform trading decisions, but it wasn't solving the problem of congestion on the grid and how do you make the grid work more efficiently.
Boy, I need to learn more about energy trading. That is fascinating to hear.
It is, and it's a fascinating industry. But myself and my co-founders began incubating the LineVision business within Genscape, really saying, can we build on this sensor technology, but instead of selling it to traders, actually sell it to the asset owners, sell it to the utilities to help them run their grids more efficiently. That was back in 2016, 2017, we started getting enough traction with utilities who we were doing trials with to spin that out as a separate company in 2018, raise a bit of money. And yeah, that's the early origin story, I'll say.
And with this, you were contemplating now a technology that would need to work hand in hand with the transmission grid as opposed to working with farmers sitting underneath it, putting something pointing up at the sky, right? You're talking about needing access to the power poles and access to transmission infrastructure. Is that correct?
Absolutely. When you're selling to utilities, it's a very different proposition in terms of the security of the data, in terms of ownership of the data, in terms of deploying the sensors on their assets. And so that also was a reason for spinning it out into a separate company. It really couldn't continue to exist, both selling to market participants and selling to the regulated utility asset owners.
On who you're selling to, just to clarify as well, I would presume you're selling to utilities, but also selling to other owners of these transmission assets, which might be the complicated makeup of folks who run our grid today, which, as I understand it, are these like independent system operators and regional transmission operators, and some of which are pseudo quasi-governmental nonprofit groups. These are the folks you're presumably know well and work closely with. Is that right?
Absolutely. We know them well. We work closely with them. But our customers very much are the utilities who own the lines. And so they ultimately are responsible for setting the ratings, managing the ratings on their line.
So even for like these interstate transmission lines, it's still a utility who actually owns it somewhere.
Absolutely. And they pass the ratings on to the system operator. So Duquesne Energy, who's a customer of ours in Pennsylvania, is a part of PJM. We provide the ratings data to them. They in turn share that with PJM, who is doing the broader real-time and day-ahead power flow modeling and dispatch.
Okay, that's very clarifying to me. I guess I didn't realize that that's how the transmission grid ownership is managed. Feels complicated when a line is stretching across multiple utility jurisdictions, how that sort of line ownership is managed. But maybe it is like the interstate highway system where it's one road, but it's broken up by different state responsibilities.
Exactly. It is just a somewhat balkanized structure, both from a regulatory standpoint and even from an operation standpoint. But that's just a function of how our system has evolved.
Okay, thanks for the background. So why don't you describe the products that you sell, how they work, and what they actually look like? That might be helpful for me and for our listeners to be able to follow along.
Sure. So what we do ultimately is it's monitoring transmission lines. The product itself both has a hardware component and a significant software component. The hardware component is a non-contact sensor that mounts on the transmission tower. So it never touches or actually gets close to the energized lines, which is very useful because it means that the utility doesn't need to schedule an outage and de-energize the line, which may sound easy, but it's not like flipping a circuit breaker in your house. These are the backbone of the power grid, and it can be very difficult to shut off these very high voltage lines. So what we use is a combination of sensor technologies, but one of the most important is LiDAR. So it's the same technology that's used in autonomous vehicles. It's spinning lasers that are bouncing off objects in their field of view. In our case, we're mounting them at an angle from the tower to be able to look up at a cross section of those conductors and can get very precise measurements and really kind of a rich point cloud of where each of those conductors are in space. And the reason that's important is that a hot conductor is going to sag more than a cool conductor will. And so by knowing the conductor type and knowing the physics of it and kind of having survey data, we can translate the sag of the conductor into the temperature of the conductor. So we know exactly how much wind has been cooling that line, and we can calculate what we call a dynamic line rating. So we can help utilities, kind of going back to our earlier conversation, go from these very conservative static ratings to taking advantage of the fact that wind is cooling the lines and they can safely put much more power through it without exceeding the actual thermal limit of the wires.
I see on your website you say that you were able to achieve up to 40% capacity boosting on these lines. That's a substantial gain.
It really is. If we think about one of the things we're doing is literally we are a grid infrastructure company. We're building grid capacity, but we're doing it using relatively low-cost sensors and analytics rather than poles and wires. And back to the challenge that our industry has of doubling and eventually tripling grid capacity, we're going to need all the above. We're going to need new lines. We're going to need to reconduct our existing lines. But we represent kind of the low-hanging fruit of saying, let's start by getting the most out of the existing wires.
Hey everyone, I'm Yin, a partner at MCJ, here to take a quick minute to tell you about the MCJ Collective membership. Globally, startups are rewriting industries to be cleaner, more profitable, and more secure. And at MCJ, we recognize that a rapidly changing business landscape requires a workforce that can adapt. MCJ Collective is a vetted member network for tech and industry leaders who are building, working for, or advising on solutions that can address the transition of energy and industry. MCJ Collective connects members with one another, with MCJ's portfolio, and our broader network. We do this through a powerful member hub, timely introductions, curated events, and a unique talent matchmaking system and opportunities to learn from peers and podcast guests. We started in 2019 and have grown to thousands of members globally. If you want to learn more, head over to mcj.vc and click the membership tab at the top. Thanks, and enjoy the rest of the show.
I mean, if you have to double or triple capacity, if you can achieve, it sounds like 40% maximum kind of boost, but let's say even on average 10 or 20% boost, presumably that's millions and millions or hundreds of millions of dollars of saved money in terms of running new lines potentially, if you can gain more out of what you already have.
Correct. And what's important is also that a lot of those other approaches to building grid capacity are more infrastructure heavy, and they take time. It takes 10 or more years to permit and build a new line, particularly if you're going across state lines and different jurisdictions. We can deploy dynamic line ratings and unlock capacity on existing lines in a matter of 2 or 3 months.
You're avoiding all the NEPA reviews and all of that these utilities are having to do anytime they want to run a new line somewhere.
Exactly.
How much does seasonality play into this phenomenon? If sounds like heat is the main thing that we're trying to avoid in terms of having greater throughput. So does that mean in general, in the middle of winter in the Midwest, in theory, you should be able to have higher capacity if you have any degree of sensing that says that you're not at risk. Or is it truly more wind oriented, as you said?
So wind is probably the single biggest factor in unlocking incremental capacity through dynamic line ratings. And even in the standard approach of what are called static ratings, there are summer and winter ratings, but it's very crude. So sometime in the spring, from one day to the next, suddenly we go from winter ratings to summer ratings. And of course, that next day might actually be much colder than the previous day.
Goodness knows our weather system is not very stable.
Exactly. But one of the other things, we talk a lot about dynamic line ratings, and that's certainly what has been driving the vast majority of our customer engagements. But really what we're talking about here is a monitoring platform. And that same monitoring platform is also able to provide really powerful benefits in terms of extending situational awareness beyond the substation. So being able to monitor these lines, use a digital twin approach to say, this is where the lines should be in space, and our sensors can tell us where they actually are.
You said it's this sort of drooping, sagging phenomenon that is really the signal you're looking for.
That's right. And that can happen just with all the physics of a heat balance equation and the thermal factors. But there's also aging infrastructure and extreme weather and ice that can build up on lines and damage to components. And so that's one of the other applications that we're seeing growing interest in from our customers, which is, how do I make my system as safe as possible? And how do I get alerts without having to roll a truck to go inspect every mile of these lines? So we can detect things like structural damage to a tower. We can detect if one of those lines is hanging lower than another because of a broken insulator, if there's ice on a line. And maybe most importantly, and kind of relevant after what's happened in LA recently, we're very good at measuring hyperlocal wind speeds. And we do that through a combination of data from our sensors, computational fluid dynamics, and weather model data to be able to get down to a span-by-span calculation of wind speeds, which can be a really important criteria in determining when is it no longer safe to operate these high voltage transmission lines.
And you pull all of these off your own non-contact sensors, or these are other data sources you're ingesting?
It's more the latter. So it's marrying sensor data together with running computational fluid dynamics models, and we have some weather partners that we work with.
Typically, when a transmission line is installed, what is the expected lifespan?
So 40 years is kind of a nominal expected lifetime, but I've actually been out in the field and I've seen lines that are 100 years old that were built literally in the 1890s. It's incredible. And I saw a statistic recently that more than half of all circuit miles of lines in the US are 40 years old or older. So utilities are operating a lot of these lines where they don't have great data. They may have passed hands when mergers and acquisitions occurred over the years, and maybe operating lines with assumptions that haven't been validated.
Just as a history nerd, imagine one line that started its life taking power from a coal plant and powering an Edison light bulb somewhere, to that same line taking power from a solar or nuclear and using it to power an AI data center, and the electricity is running through the same conduit. That's pretty incredible to think about, really.
It really is. And frankly, it's amazing how reliable our grid is given all that history. But where this is all just kind of part of this platform, we have what we call our line health module that is able to assess the health of the conductor today instead of just looking back on the original design criteria and assuming that's still valid.
And similarly, like utilities are hiring you essentially to do this type of monitoring because, again, today, otherwise they're, I assume, have to employ people to go out and spot check these lines.
Absolutely. And I wouldn't represent that adding LineVision eliminates the need to do inspections. This is really supplemental to the periodic inspections that occur, whether they're walking the line or flying drones to do inspection. But those typically occur on an infrequent basis, maybe every 6 months or a year or two.
That was a good Johnny Cash reference, whether you meant to do it or not, about walking the line. So I'll take it.
So where LineVision adds value is really that continuous monitoring. And that's very complementary to the kinds of inspections that utilities are already doing.
And as I understand it, there's like 750,000 miles of these transmission lines out there somewhere in the US. How far are we from a world where they are all monitored?
That's a really good question. Selling technology to utilities, to regulated utilities, is not for the faint of heart, right? I think it's been said that no utility wants to be the first to deploy a technology. And so that can make it hard to break in. But the flip side of that is that all utilities really are doing exactly the same thing in their respective footprints. And the beautiful thing about this industry is they look to each other and they're not in competition with each other. They're really trying to learn best practices. And so when a technology does come along that is cost effective and has real benefits in terms of whether it's efficiency, operating the grid more efficiently, or improving safety or improving reliability, it can become the industry standard fairly quickly. And so I tend to be an optimist. I'll put that out there, and I'm not entirely impartial, but I do believe that we're seeing accelerating adoption. We have just a great roster of leading utilities who we work with and really treat as partners: National Grid, AES, Southern Company, NV Energy, which is part of the Berkshire Hathaway Group, Excel, Avangrid. And they're also ambassadors, right? They're talking at industry events about how they're using our data. And so I do believe that it will happen, that it's inevitable, to borrow the name of the podcast, that this becomes industry standard practice.
And are you feeling more pull from new projects coming online, which I know take a long time, a decade plus, that are saying, hey, we want to be monitored from the start, as opposed to why install lines today that are dumb from the beginning? Or are you feeling more pull from the fact that this aging infrastructure needs to be monitored to avoid calamity, as well as, hey, maybe we can squeeze a little more juice out of these oranges while they're still up there?
Really good question. Just from a size of opportunity standpoint, there are shockingly few new lines, new transmission lines being built. So the vast majority of our business is really installing on existing lines and helping to unlock additional capacity there. One of my mottos is no more dumb lines. So if you are spending the hundreds of millions of dollars to build a new line, it's unconscionable to not equip that with monitoring technology from the start. One of our projects is with New York Transco. It's running down the Hudson River Valley into New York, and it was equipped from the start with our monitoring technology. But yeah, the short answer is the larger opportunity is really on existing lines.
And Hudson, you all raised a Series C a few years ago, so you're right there in that sort of growth stage from a business perspective. Maybe share a little bit about the financing history of the company. You talked a little bit about how you originally incubated it and spun it out from Genscape, but maybe share a little bit about how you've grown it as the founder.
Yeah, no, it's been an amazing journey. We've really tried to focus very much on partnering with a small number of customers and really not looking as our growth model to just kind of signing up more and more customers, but saying, how do we grow with those customers? How do we go from initial pilots to designing success criteria together with our customers and earning the right to move to operational projects? So the distinction being, a pilot might be funded by R&D and really is just kicking the tires, but it only really delivers benefit if our data is being used in daily grid operations. And so that first operational project with each of our customers is a pretty significant investment, both on our part, but even more importantly on our customers' part. But then we earn the right to expand. We have integrated into the EMS, that data is flowing to the system operator, and we become a tool in the toolbox as they see bottlenecks on their grid elsewhere. So that's been great. And from an investment standpoint, we've got a really good set of aligned investors, including National Grid Partners, that's the venture group of the utility, including Microsoft's Climate Innovation Fund, including S2G, including Climate Innovation Capital. They've been very supportive. We are a fairly capital efficient business. Yes, there's a hardware component, but it's not as if we're doing battery manufacturing and need $500 million to build out our first factory. We're using contract manufacturers, and we really view ourselves more as a data company than we do as a hardware company. So we don't have massive capital needs in order to grow, but we're still focused primarily on the North American market, and we also have big ambitions in terms of really kind of building out the platform. So having this not just be a dynamic line ratings solution, but one that is continuing to enhance applications around situational awareness, around asset health monitoring for our customers.
Are there any companies outside of the energy grid utility space, maybe even in different sectors, like you came from telecom originally, that have served as sort of a role model for you on the type of business you want to build?
I'm going to throw one out there, which is totally left field. One company that when I study innovation and look at the innovator's dilemma, for example, the fear is that the trap is always getting caught in your own technology and limited by your own technology. I look at a company like Netflix, who originally was sending DVDs by mail and totally kind of flipped their business to say, now we're a streaming company and we're delivering data through broadband and services through broadband, and then pivoted again to developing their own content. And to me, that's a sign of a company that is not trapped in its own technology.
Can you share how you might think about applying that to your business today?
Sure. Yeah. I mean, it's really kind of saying, what are the problems of our customers that they're looking to us to solve, and not looking narrowly at the fact that all of the data and all of the solution has to come from the sensor. How do we harness a broader suite of data to end partners to solve those problems?
This would be the whole software OS that you've built, essentially, that is bringing in signals, the whole digital twin of their system. Like, how can you expand off of that side of what you built?
And I think I'm also really excited about, I think we're just scratching the surface of harnessing the power of AI to be able to mine all this data that we're capturing from these assets and use it to better and better detect anomalies, not just in real time, but be able to predict failures. And as we continue to expand and have a larger and larger set of data that we can train on, like, that becomes almost kind of a virtuous cycle for our customers.
I'm going to ask a totally curveball left field question, which is thinking about different ways that your business could be applied in the future. How much does cybersecurity and physical security, those are two different things, but how much do those come into what your customers are looking for? You're talking about an incredibly critical piece of infrastructure that is generally unmonitored today. Like, that is terrifying, both from a cybersecurity and physical security threat perspective.
Great point. There's kind of two sides of that. One is adding monitoring can improve our grid security. And it's kind of shocking if you step back and look and say, these lines that really are powering our economy are not monitored today, largely not monitored. And so when we talk about non-contact monitoring, we can also detect threats, kind of a broad set of threats there. So we feel like we can be a big part of how do we improve the security of this critical infrastructure. But there's a second component to this, which is, as we discussed earlier, we're operating in the high voltage transmission world. That's in NERC terms, NERC being the entity that's responsible for ensuring the security of the North American power grid. We're in the bulk power system. And so we have invested significantly to make sure that we adhere to, or we help our utility partners adhere to NERC critical infrastructure protection standards. And so that really means that this cannot be in any way an attack vector through which a bad actor could compromise the integrity of the power grid. And I won't go into a whole lot of detail on exactly how we do that, but that's really kind of fundamental to our system architecture.
Yeah, I suppose the counter argument one could make is in a system that is unmonitored and doesn't have software in it, there's actually less cybersecurity vector than if you start adding software and AI and automated routing into our grid, and you maybe introduce more layers for cyber attackers to come in at that point than you do if you're just a dumb system.
Yeah, I think that's true. And that's why there's a lot of investment on the part of NERC and utilities and vendors like LineVision to ensure that we're not opening up those threat vectors.
Makes sense. Hudson, what else should we cover? Anything else that we haven't talked about today that is relevant and interesting for our listeners to understand about this broad space of the transmission system and how we can help modernize it?
Well, we haven't talked that much about our customers. We exist to add value for our customers. And so I'd like to share just a little bit about just in the last few months, we have announced contracts with Southern Company, so specifically their Georgia Power utility. We talked about load growth. Georgia Power is probably ground zero for load growth in the country.
That's Vogtle, right? That's where we've now put a bunch of new large-scale nuclear reactors in place.
Yeah, they've benefited significantly from onshoring of manufacturing. There's a lot of data center load growth there. Chris Womack, who's the CEO of Southern Company, has created a culture in that organization. We're going to find a way to say yes to our customers. We're not going to turn them away if they want more grid capacity. And so they've come to LineVision to basically as part of the solution for how do they keep pace with load growth. One of our other recent customers is NV Energy. So Nevada has also just tremendous load growth, largely fueled by data centers and AI. And they're also experiencing wildfire risk as they look to their neighbors to the west. So we're excited about that partnership. And there's a few others, but the point being that the utilities who are really most acutely seeing the pressure of loads on their system are turning to us as solutions, and that's very gratifying for us.
What I'm hearing you say is also a geographic shift in where and how these data centers are built that is probably changing how these utilities have to think about this very rapidly, right? I think historically, the data center corridor in the US has been Virginia, right next to the communication hub and nexus, all the undersea cables we talked about, all of that. And now the data center world is moving to places where they are maybe able to co-locate near clean energy more easily, right? So Nevada, where there's heavy solar, West Texas, where there's a lot of solar and wind, for example, Georgia, where there's an influx of new power generation coming online. And that sounds like completely shifting how these utilities are having to move electricity around within their local jurisdictions.
Absolutely. Yeah. I mean, I think grid capacity is the new gold. And so you'll see data centers expand where they have grid capacity. I will say we're seeing expansion everywhere. And there's some other big announcements that are not yet public that I can't talk about in some of the areas you referenced, but you're absolutely right.
That's interesting. I was saying generation capability. You're saying actually, no, if you have the grid capacity, you'll find the generation is a little bit what I'm hearing you say.
It takes both. I think the bottleneck in many cases is the grid in terms of interconnection. Generation, there's plenty of generation connected to the grid. As you add grid demand, you move higher in the supply stack and prices may go up. But I think the factor that is preventing loads from being able to connect is more grid capacity than generation.
Hudson, this has been great. I really appreciate you taking the time to come on and share what you guys are building and help us learn a little bit more about the broader context of the space in which you operate.
Thanks so much, Cody. Really enjoyed the conversation.
Inevitable is an MCJ podcast. At MCJ, we back founders driving the transition of energy and industry and solving the inevitable impacts of climate change. If you'd like to learn more about MCJ, visit us at mcj.vc and subscribe to our weekly newsletter at newsletter.mcj.vc. Thanks, and see you next episode.